everybody. Sorry, there was some technical glitch, so Murphy's Law is always there, no matter what. Anyway, today we're going to talk about universal JavaScript, especially with web application, using React framework. So I am Luciano. I am a software engineer at Planet 9 Energy. Planet 9 Energy is a new startup company that provides energy in the UK market and is actually focused on providing new technology solutions, especially to enable their consumer and industrial customers to see a lot of small details about their electricity consumption. We are building a very interesting infrastructure using AWS Lambda, so everything is serverless. So in case you are interested to these kind of topics, please catch up with me later after this talk. Anyway, you can find me online on GitHub, on Twitter, and there is also my blog. I am also the co-author of this book, Node.js Design Pattern, together with Mario Casciaro. And if you are interested in Node.js and you like design patterns, or you just want to understand better how to apply specific traditional design patterns in the JavaScript land, just give it a try, because I think it can be interesting for you. So what's the agenda for today? We are going to see what does it mean, universal JavaScript. We are going to see which companies are already using it and why. Then we are going to see what are the common problems that you generally need to address when you need to deal with a universal JavaScript application. Then we're going to switch to a practical exercise. So we're going to build a very small application. At first, we are going to build it just as a single-page application. So it's going to work only on the front end, only on the browser. And then we are going to make it universal. So let's kick it off. So first of all, what does it really mean, universal? So probably you already heard about the term isomorphic. And that's because for a long time, at least I guess 2 years from now, what is today called universal was before called isomorphic. Then this bunch of hipster developers came into a fight and they decided, okay, let's call it universal because it looks better. If you really want to understand the reasons, there is a link there and you will find the original post that generated all this switching to a new term. By the way, regardless if we want to call it isomorphic or universal, what I really mean with this term is building a JavaScript application in a way that the modules that we write can run without any change or almost any change in different environments. In particular, we are going to focus on the browser, so the client environment, and the server, so Node.js. And we are going to write an application where the modules that we write can run both in Node.js and in the browser. But in reality, the concept of universal JavaScript is a bit broader, because there are people that are starting to use this kind of terms also when they talk about building desktop applications with JavaScript or mobile applications with JavaScript. And there are even people crazy enough that are trying to do that for hardware. So what are the advantages of universal JavaScript? Why is it so interesting? So first of all, it's interesting because when you have both JavaScript, let's say in a web application, when you have both JavaScript on your server and on your frontend, there is no more language switch. So in theory, all your developers, unless you have other technologies in all your stack, will need to worry only about writing JavaScript code, so JavaScript modules. And this can be an advantage in terms of productivity, in terms of less duplication. So at some point, we can also talk about maintainability of your code. Then another important aspect is search engine optimization. Even if Google claims since, I guess, 1 year now that they are able to crawl even single-page application built only for the browser, so only running on the front end, in reality, it doesn't always seem to work very well. And it's not just a matter, when we talk about search engine optimization, it's not just a matter of providing the content to the search engine crawler. But sometimes it's also important that the crawler understands what is the status code of a specific page. Let's imagine we are dealing with a not found page. So we generally want to return a 404. If you ever done a front-end only single page application, you will know that it's not something that you can really achieve. Same story if we talk about redirects. So if you have a redirect, how are you going to tell that some URL at some point needs to be mapped to a new URL to the search engine crawler? So with universal JavaScript, you can put the server there to deal with this stuff, and it's going to make search engine optimization much better. Then one very important topic is faster perceived load time. We say perceived because it doesn't necessarily mean that your pages loads faster, but in terms of the wall time from the beginning of the request from the user seeing something on the screen. But in practice, what happens is that given that the server is going to provide all the HTML code to the page directly, the browser is going to be able to render things much faster. It doesn't need to wait for JavaScript to be fully loaded to start to create the HTML. So that's why you have most of the time less flickering, and you have the impression that your page are loading faster. So who is already using universal JavaScript in the wild? Netflix, probably one of the very first companies even talking about universal JavaScript. Airbnb as well, big promoter. WordPress, they redesigned all the admin panel for WordPress.com using a totally Node.js and React universal application. And Dropbox as well is using this kind of approach. Okay, in theory, looks great, right? Very nice. But if you ever look into it, everybody says it's complicated. Probably it is. Let's see why. So it might be complicated because as soon as you start building a universal JavaScript application, you will have some common typical problems. First of all, okay, I want to write modules in JavaScript, in Node.js possibly, but then how I'm going to expose this module to the browser? Because we know, yeah, it's similar, but it's not totally the same. And there are some tools that helps us with that. For example, we have UMD, Universal Module Definition, System.js. They help us in loading our modules also in the browser. But most of the time, we also need to transform somehow this module, because in the server, we program in a certain way, and it doesn't always match what we need to do in the client. So we have tools like Browserify and Webpack that helps us to fill the gap and to compile, let's say, or transform our code in a way that the browser can understand. Then there is another issue. Okay, most of the time, especially when using frameworks like React or Angular, we define most of our views in terms of components. And we are used to think, okay, this component is going to be rendered by the browser at some point when I'm going to do something. But how are we going to do that also on our Node.js application? So we need to find a way to be able to render the exact same content, the exact same experience, let's say, that we can have on the browser on the backend. So the server needs to know how to render every specific URL in your application. We are lucky enough that React.js and Angular 2, they already have some built-in solution to do that. There are also some new solutions like Next.js. And a topic that goes hand in hand with this is, okay, we also need to match the URLs, both on the server and on the client, and render the same content. And for this, if we are in the React land, we can use React Router, or there are other solutions that are more, let's say, framework adaptable, so we can use them in different frameworks, like Router 5 or Universal Router. Then another big issue is, okay, generally I'm going to need to consume some data from some source. And we are talking about universal data retrieval. So this source needs to be accessible both from our Node.js application, which generally is easy because on Node you can query a database, you can read a file, you can do a lot of stuff that generally you cannot do on the browser. But yes, we need to find a way that works in both environments. So generally, one of the most used solutions is to have an API server that expose all the data that we need to access, and then we can access the same data in the same way, making API calls either on the server or in the client. And to do that, we have different libraries like HTTP proxy or Axios and universal fetch. Another big issue is managing the state. So generally, your user will be probably authenticated. You will need to show different data depending on who is the user and what is his history in the page, or what he wants to do in that specific moment. So you need to have a way to describe your current state for the current user. And it's not trivial to find a way that works, both seamless, both on the server and in the client. There are some solutions that are using Redux or MobX or Cerebral. And finally, yeah, why not use any new fancy version of JavaScript or alternative languages like TypeScript or Elm or ClojureScript? It makes sense to use these tools because most of the time it's going to make our life easier. And if we want to use a framework like React, you should really use JSX. It's not mandatory, but without that, your experience is going to be so bad that you are probably not going to use React at all. So we need to use that, and this is something else that we need to manage in all our universal JavaScript applications. But we have tools like Babel or other transpilers that helps us with that. OK, that's more or less the feeling that you should have right now if you never heard these things before, right? OK, but yeah, we are developers, so at some point we should stop complaining and we should start to see, OK, let's try to build something. Let's do it. So let's choose some technology. We want to use some tools, and we are going to use Webpack, React as a framework for the view, React Router as mechanism to manage the routing, and Express to build our Node.js server. Now, what are we going to build? Well, I am a big fan of judo, the martial art. So I already built a small application for an article that I published on scotch.io. You can find the link there. So today we are going to build the same application. We are going to make some slight improvements. And I choose this application because I think it's very simple, but at the same time it's something tangible. So we are going to have the impression that we are building potentially a real website. Let's see how this application looks like. So basically you have a first view where you can select different athletes. And then for every athlete you have a page that you can scroll and you will find some information about these athletes, like their name, where they are from, the year of birth, their Wikipedia page, the medals that they won, and things like that. So it's very easy, a very easy application. We have just two sections, so an index and a detail page. OK, how this is going to work? I hope it's visible enough. So basically the idea is that we want to achieve this thing. So we want to load any page in our application. The first time we load this page, we need to download all the resources needed to render that page. So we are going to download our HTML page, the images, the CSS, the JavaScript code. But then, as soon as we move to another section, let's say by clicking one of the names there in the menu, we want to switch to the new section, but only download the new resources, because everything at this stage happens just on the front end. So the first time here, we get everything from the server, and then the React app is initialized. But then, as soon as we keep navigating our application, we are just going to need to download the new stuff that we need to show in the page. But again, what if we want to refresh this page? So in that case, we want, let's say, like trigger a curl request to download the page. And we want to get, again, all the content, because this is going to happen when a search engine crawler is going to go to one of our pages and try to understand what is in this page. So you can see there, I hope, at least. Well, you don't need to understand the code, but trust me that there we have all the content of the page. So, OK, let's start to see some code. First of all, let's talk about the data that we're going to use. It's a very simple application, and I want to make it simple. Probably it's not going to be ideal for a real use case, But in this case, we have, I think, 5 or 6 athletes. So it makes sense to have a very simple JavaScript module that just exports an object, actually an array, that contains all the objects that represents every athlete. You can see that for every athlete, we have attributes like ID, name, country, year of birth, an image, another cover image, a link to their Wikipedia page, an array of medals, and so on. So very simple structured data. So now let's move to the React components. I'm going to show you one of the possible ways we can structure this application using React components. So first of all, let's see our main level component, the layout component, which basically just gives us the structure of the page, actually the fixed structure of the page, meaning that for every section of our page, we always want to see, in this case, a specific header, a block of content that will be changed depending on the page that we are in, and then a footer. So let's see the code. I hope you already have some familiarity with React code. If don't, in the next example, we are going to see always better, more or less how it works. I'm not going to go into the very fine details, but I hope it's going to be understandable anyway. Feel free to ask me a question at the end if something was not clear in this stage. So our layout application, as I told you, is going to have a render function that basically just defines the codes that let's say, kind of HTML code, or if we want, a sort of representation of the DOM that needs to populate our component. And it's going to contain an header section, then the content section, and you can see there that it depends from something called props.children. And when it comes to the routing, we are going to understand who is going to populate this part of the application. And then at the end, we have a footer section. And basically, you can see that it's almost plain HTML there. OK, then let's move to our main page, what we call the index page component. So when we are in the first page, we want to display the list of the athletes that the application showcases. And so basically, we want to have a component that describes this specific list. So the first thing to notice is that we are importing our database module. Let's call it this way. It's not really a database, but gives you the idea that it's where we get the data. And we are going to use this module to iterate over all the available athletes. And for every athlete, we just call the component athlete preview, and we pass it all the data regarding that specific athlete. So basically, we are delegating to a subcomponent to render every single athlete in the list. So what are we doing here is just an iteration through the array and saying, OK, for every element, I want to use this component to render the specific element. The specific element, for example, can be this central one or any of the other athletes there. It looks like a card. So we can call it athlete preview. And actually, we're going to use this component to see better how a React component looks like. I already told you that every React component needs to have a render method, or if you create React components in the form of pure function, basically, we need to have a function that accepts some inputs that generally we call props and returns this sort of JSX or DOM tree representation. So in this case, we want to render, for example, what you see there, this specific image. And we will see that we have a main level tag, which is called link. In this case, it's just notice that this specific tag has an uppercase letter. And the convention is in React that when you have an uppercase letter, you are talking about a custom component. So it's not a raw HTML tag, but there is some logic there that gets resolved in order to render the component. In this specific case, is a utility from React Router, and it creates basically a link tag, an anchor tag, so an A tag, that links to a specific route that we define here as an expression that basically is athlete / whatever is the ID of this specific athlete. So all our component is going to be clickable, and when we click it, we go to the specific page for this athlete. Then we are going to show the image of this athlete. So we have an image tag. Okay, we don't need any high-level abstraction for that. We just link the source of this image to the specific value that we expect for this athlete. And again, we use a JavaScript expression there. Then we want to show its name, and we use a basic h2 tag. And we use for the content of this h2 tag, again, a JavaScript expression. Then we want to have as well this little icon there in the top right corner that shows an image that basically is an icon for a medal, and the count of the medals that this athlete won. So that's basically it. More or less, if you don't need to create very complex React component, every React component is going to be a function that, given a specific input, just needs to render a specific JSX or return a specific JSX code. So now let's move to the other section. So when we click to in the athlete preview component, we want to switch to the athlete page component, which we see here, which is probably a bit more complex because we have more information, but I'm going to show you that at the end it's still just a matter of combining React components in the right way. So in this specific case, this is our code. Looks like a lot, but I'll show you it's very simple, and let's zoom in. So basically what we do is, what we expect from this component is to send it a specific ID for the athlete that we want to render, and we will get this ID from props.params.id, which is something that gets populated by the router. Then the first thing that we want to do is to check if this ID really exists in our page. If it doesn't, we just return a not found page, which means that we are going to render the not found component that we will see later. Otherwise, it means that we have the athlete, and all his data is going to be stored in the variable athlete. Then we can reference other subcomponents, so we just split the work to build this interface to different subcomponents. And we use athletes menu to render the menu that you see here on the top. We are going to see it better later. And then we render the header, which is the nice image with the picture of the athlete. And then we have a section where we show the description. So we say this athlete is an Olympic medalist from France or whatever. And notice that when we say France, given that we want to display the nice flag of the country, we reference again another subcomponent. So basically we are always delegating to render more complex data to a more specific component. So we have this kind of flow, like top to bottom, and we try to push more specific data to more specific components. So then we have the other section to display all the medals. And again, we delegate, so basically we go through a loop over all the medals, and we delegate the task of rendering a single medal object to another specific component called medal. And finally, we have just a link that allows us to go back to the index page. So this is the athlete menu. Let's see again how it works. So again, it's very simple. We just iterate over the list of all the athletes, and for every athlete, we create a link component. And another thing to notice here, because it's just very handy from React Router, we can use the attribute active class name, which allows us to assign to the specific link in the menu a specific class automatically only when you are in the route that is matched for that specific link. So we can have, like almost for free, the possibility to render in a different style the current link. So then let's see the flag component. Basically, it's a very simple component that just render an image, and then we have the option to say, okay, do you want to show for this component the name of the country or not? I put this there just to show you that you can do some more elaborate logic within the render function. In this case, we have there the props.showName and whatever. So we go to the end side just if we set a truthy value to the show name property. And in this case, we are going to add the name of the country close to the flag. Then let's see how the medal component work. So another little thing to notice here is that in our little database module, we reference the medal type with just a letter. So we say G for gold, S for silver, and B for bronze. So we have there an hash map, basically, that tell us how to associate that specific type to a descriptive name. And we use that inside our render function. And as well, we use all the other props that we get for a medal. So we get the year, the city of the competition, the name of the event, the category, and things like that. So it's very simple. It's looks like a template at the end. And then finally, we have the last component, which is our not found page, which basically is a plain static HTML text, where we basically say, okay, 404 as a title, page not found as a subtitle, and then we want to have a link to the main page. Okay, great. So we built all our React components. Now let's see how everything comes together given a specific URL. So we want to display the right pages and the right components given a specific URL. So basically, we are going to have two routes. The first one is the index page, which is just slash. And the second one is the athlete page, which is going to be mapped to athlete/ID, where ID is a placeholder. So basically there we are going to have like a slugified name of the athlete. And this is what it gets passed to the athlete page in order for us to load the proper data for the page. So how do we describe these routes? So basically, React Router allows us to describe routes as components. There is a very similar approach. So basically, you just need to return a tree of elements that you can describe in the JSX format. And the main element is a route path. And then that maps to just slash. And it tells us that all the routes that are inside this component just needs to use slash as a prefix. Then we have the index route. That means, okay, when you are using just slash, just the plain prefix, you need to render a component that is called index page in this case. Instead, when you have a path that is athlete/some ID, you need to use the athlete page component. And finally, we want to have a sort of catch-all route that gets every other route and displays a not found page using the not found page component. So we built just a basic description of our routes. Now we need to map them to a proper router object. And to do that, we just import our routes from before in another component. We define a router component there. In this case, we want to use the hash history. And we are going to see later what this means. And we pass our routes there. Then we have also this little utility that allows us to say, okay, when you move from one section to another, I also want to scroll back to the top, because that's something that doesn't come natively with React Router. So sometimes you have this kind of a weird effect that you click something in the bottom of the page, and everything changes, but you stay there in the bottom of the page. This way, we just scroll up to the beginning, and it looks like a regular click in a regular web application. So now the last piece is, okay, now we have the routing, we have our components, we know how routes are mapped to components, but we don't know how to bootstrap our application. Let's build a very little script that just takes our apps router, and when we finish to load the page in the browser, we just say, okay, let's use the React DOM functionality to render these routes inside a DOM element, which is main. So we also need an HTML page, of course. And this HTML page is going to look very basic, because we are going to have just an head section that contains some metadata that we want to provide mostly for search engine optimization. And then in the body, we have this main div and all our React application is going to live inside this main div. And then we have a script that we generally call bundle, that is kind of a compiled version of the code we saw earlier, the JavaScript code, that gets run from the browser when we load the page. So basically, it will contain all the React libraries, all the code that we wrote for our custom components, and our front-end Lidl application to render the route. So, okay, how do we build this packaged version of our application? In order to do that, we use Babel and Webpack. So we need to provide a meaningful configuration for Babel and for Webpack. In the case of Babel, it's very simple because we are using some standard, let's say, extension of the JavaScript language. So we are using the React extension and we are using the ES 2015. And in Babel, we already have some presets, so basically some extensive configuration that tells Babel, okay, my application speaks React and ES 2015. Do whatever you need to do in order to make it work in any browser. So basically, we tell this with just this line of configuration. Then we need to use Webpack. What does Webpack do? So basically, Webpack says, okay, I'm going to understand everything you are going to need in your application. So you are going to give me an entry point that you see there, basically a JavaScript file, and I'm going to resolve all the requires, and I'm going to pack everything together. So basically, Webpack allows us to import in our final bundle just the libraries that we are really using. And we don't really need to worry about specifying every single library in a, let's say, in a text file or in another form of configuration, because it's going to resolve everything from our code. We are going to tell Webpack to store the file in a specific folder, and then we are going to tell Webpack to invoke the Babel loader every time we find a file in our source folder. And this is going to actually trigger the Babel conversion from React and ES 2015 to plain JavaScript code. Okay, so let's build this JavaScript bundle. We just need to invoke Webpack, and after some seconds, you will see that it outputs a JavaScript file called, is there somewhere? Yeah, bundle.js. Anyway, one last missing step before we can see our application running live is to have some kind of server that allows us to serve static file. Given that we are going to need a more elaborate server later when we are going to add the universal piece, we will also use Express in this case. We don't really need to, but it's easier than to transition to a universal application. And basically, this application just uses the express.static middleware to say, okay, offer to the client whatever is in this folder. And in this folder, we have all our assets, our bundle, our index file. So all our application is packaged there. OK, ready to test it? Let's see if it works. OK, so I'm going to go quick because we are out of time. This is our front-end only application. Just notice that when I switch section, the URL changes, but we have an hashtag before the specific URL. And this is because we are doing everything only on the front end. So if we want to refresh the page, we need to always point to our index HTML. So basically, this is our application. And the only important thing is that if we see the source, we have no code that describes the content of our page. Now, let's make it universal. I'm going to go quick, and it's going to be very easy. We just need to add server-side rendering and routing, which basically means that, first of all, we want to switch to a proper routing. So we are going to switch from hash history that uses the hashtag and the fragment part of the URL to describe routes to browser history that uses proper URLs. And that's very easy. It's just changing 2 lines. Then we are going to need to use whatever template language in order to allow the server to inject some code in a specific part of our HTML. And in this case, we use a.js, and we just need to copy our index HTML into an a.js file and say, we want the markup, the React markup to be shown there. So finally, let's see the most interesting part, I think, how we build the universal routing and rendering part. So we need to import few libraries in our Express application. We need to use the EJS framework as a view system. And then we need to use we create a route that matches every URL. So whatever is not a static resource, like a CSS or an image, it goes there. And there we have to specify the logic to map the current URL to a React router URL. And to do that, React Router exposed us a method called match that we can use on the server, which basically takes as parameter the list of routes, you can see there as a parameter, and the current location. And it calls a function providing specific input arguments. So we can have now different cases depending on the argument that we get from the React router. And the first case is, OK, something is gone wrong. I don't know what happened. There is an error. You cannot render anything. So let's just say that there was an error and return a proper 500 internal server error. Then the second case, which shouldn't really happen in our application, but in more complex application can happen, if we have a redirect in the React routes, let's say we want to map an old URL to a new one, we go to this case. We are going to have a redirect location attribute, and we need to use that to return a proper 302 code back to the browser with the URL it needs to go to. Then the last case is where we actually match something with our routes, something that we can render right now. So basically, if we have a component that we can render, we can use the first part of the if. So we have render props, and we can use the router context to render whatever is the component that we have to render. Otherwise, it means that we didn't found any route, so we can render the not found page again and use the proper 404 code that we couldn't use before in our front-end only application. And that's basically it. At the end, we just say render the markup that we get from all this process inside our template. OK, let's test it again. And we are almost done. The only things I want to show you now, this is the version 2 of our application. So if we load the code for this page, it looks different. So we have all the content there. And again, if we go to any section and we refresh, let's say, by triggering again a new view source, we have everything there. So we achieved universal rendering and routing. So very quickly, what we did, we built a single page application only focusing on the front end, and then we added server-side rendering and routing to make it universal. OK, there is still more that we can do from here. I'll leave you this as an experiment for you if you are interested. And basically means we can add universal data retrieval. I have an example in the book that I mentioned before. So if you are interested, there is a dedicated chapter about that. And we can also add universal state management, for example, using Redux. I am working on all this code in the repository that you see there. And probably I'm going to update it also adding universal data retrieval and state management. So that's it. Thank you, everybody.